You may have been annoyed in the past about how when you do digital calculations, there are rounding errors, and you don't know exactly how big those errors are, and if those errors are going to make predictions in like science experiments inaccurate simply because of your math, rounding errors, and no further issues. There's a solution for this. The solution for this is what is called interval arithmetic. And in interval arithmetic, what we do is we take an interval like this. Sorry, it's interval, not arrows. Interval. And we say this is our interval of significance. So if we are taking answers with 3 significant digits, then a rounding error of like this much is insignificant because it won't change our 3 significant digits. But if it's a 9, it could. So you have to have our interval of significance of like, okay, this is small. We have to define, okay, this is how small an error can be where it won't change a significant digit. And that's pretty simple to do. If it's big enough to change one of these numbers, it's outside the interval. If it's small enough, it's inside the interval. Then we do our calculations where we always, instead of in school where you learn you round up, in interval arithmetic you round up and down. So you do 2 parallel calculations. In this case, you always round up when there's a rounding instance. In this case, you always round down. And so naturally, those answers diverge further and further as you do more and more operations. And so by the time you're done with operations and you have answers, you have 2 answers. Because once you're rounding down, you're always rounding down. And if you're rounding up, you're always rounding up. So you only have 2 possibilities. And both of them will be, in this case, greater, in this case, less than the exact answer. But they may end up being greater than the interval. If your answer turns out to be the difference between these two, the interval, is greater than your interval of error, then that's a problem. And that means you add precision to your inputs. So what you may need to do here is you may need to have a very large amount of precision in your inputs and your intermediate calculations, like something like this, in order to get an interval of error in the answer which is within the interval of significance. So you may have to start out with something like that. And so as long as we're dealing with pure mathematics, this works great because you can always add significant digits to your inputs. And thus you can have an output which is guaranteed to be correct within its precision. The problem which can happen in applications like science, like we could use this problem to solve the 3-body problem or n-body problem for predicting where objects are going to be moving in the solar system. There's a problem though when we apply it to this case. So let's say we have an asteroid and we have a planet here, we have the sun here, and we have another planet here, and they're moving around their orbit. So this is going this way in its orbit, this is going this way in its orbit, and to be accurate, this planet needs to be closer to the sun. So we're going to say this planet's going to be right here. So they're all pulling the object in different directions. And so you got force of gravity here, force of gravity here, force of gravity here on the asteroid. Everything's moving, and the asteroid's moving this way. because asteroids do their own thing, kind of. And so you can run your calculations, but the problem is we on Earth have a telescope, and we're watching the asteroid, and we only know the position of the asteroid to a precision. Like, let's say we know the asteroid is at location 136. We don't know any precision beyond that, and that's a problem. So with this, we can still use interval arithmetic, but our answer may end up being something like 0.1 and 0.2. And we can't fix that because we can't arbitrarily add precision because it's an empirical measurement. And this is why, even with this precise mathematics, we can still end up with a solution where the asteroid could end up hitting Earth or not, and we really can't know. So that's interval arithmetic. In pure mathematics, it can solve problems like cumulative rounding errors, but there are limitations in practice. I hope you enjoyed this, and please check out my other math videos.